Last class, we started talking about trig identities and how we could use them to simplify expressions. So today we're just going to look a little bit farther into what type of expressions we can simplify with them, how we can prove that specific expressions equal different trig functions. We're just going to use them in a little bit more of a wider variety today. So if you look at this first example, we're simplifying cosine of theta times the quantity of secant theta minus cosine theta. So we still want to do the same thing. We still want to kind of follow our gut with when we see we can distribute things or simplify things. And we want to try and get everything into terms of sine and cosine when possible and then simplify. So the first thing that I want to do here is I want to change this secant because anytime I have things that are not sine or not cosine, I want to change them where possible. So I know that secant is the same thing as 1 over cosine theta. And the rest of the problem I'm just going to bring down. I'm not going to change anything except for that secant. I changed that secant to be cosine theta. So now I have two options. I could try and simplify what's inside of parentheses, or I can distribute. Personally, I'm just going to distribute because if I can get rid of parentheses when I can, I like to. So I'm going to take this cosine that's outside and I'm going to bring it in to both of my trig functions on the inside of the parentheses. When I do that, I end up with cosine theta over cosine theta minus cosine squared theta. Once I distribute, I notice that I have a cosine theta over cosine theta, which tells me that I can simplify that just to be 1. I'm going to just bring down everything else, my minus and my cosine squared theta. And then I see that I have 1 minus cosine squared theta. And anytime I see a 1 or I see a cosine squared theta and I see I've got a minus sign going on, that tells me I want to look at my Pythagorean identities and see if any of my Pythagorean identities match this. And it does. My sine squared plus cosine squared equals 1 can be manipulated to give me that 1 minus cosine squared, which is exactly what I have here. That this whole thing, 1 minus cosine squared, is exactly the same thing as sine squared. So I can change this entire thing to be sine squared. And that is my final answer because at this point I have one trig function. There's nothing else I can really do. It's already in terms of sine. So I'm as simplified as possible for this one. All right. Step it up a notch. And instead of just simplifying, now let's actually prove that cotangent squared x minus cosine squared x equals cotangent squared x times cosine squared x. So now our major rule here is that we're only going to work with one side at a time. This isn't like when we're solving an equation and we want to do the same thing to both sides. This is, we're looking to actually prove that the left side is the same thing as the right side. So we only want to work with one equation. We don't want to actually move around both sides. So I'm just going to work with the left side of the equation and try to make it look like the right side. So I'm only going to take this left side of the equation and they've given me the answer. They've told me that the left side should end up being cotangent squared x minus cosine x squared x. That the left side should be what they gave us after the equal sign. So I'm only going to use the left side and I'm going to manipulate the left side to try and get it to look like the right side. That's my ultimate goal. I'm not actually trying to combine everything and solve for x here. I'm trying to prove that they're the same thing. So I want to change cotangent squared x to be in terms of sine and cosine. Because the first thing I want to do is when I'm working with just cotangent squared x minus cosine squared x, I want to change everything to be in cosine or sine. So this is the first thing I want to change. And I know that cotangent is the same thing as cosine squared x over sine squared x. I'm going to bring the other part down because I don't need to change my cosine squared here. Now I have everything in terms of sine and cosine, but I want to combine those, so I need to get common denominators. That means that I need to multiply my cosine squared x by sine squared x over sine squared x, because whatever I do to one side, I have to do the bottom as well. And I want my denominators to be the same, and this is really a 1 here. So when I multiply, I'm going to bring my first fraction straight down, my cosine squared x over sine squared x minus, and then I'm going to bring everything else, I'm going to multiply. So over on the right side, now I have cosine squared x times sine squared x all over sine squared x. Now I can actually combine these things, so I'm going to bring them together and make them one big fraction, which means my numerator is just going to be cosine squared x minus cosine squared x sine squared x all over sine squared x. So now that I have one fraction, I need to start simplifying. So I'm going to simplify and I'm going to say, ooh, I notice that I have a cosine in the first term in the numerator and I have a cosine in the second term in the numerator. So I'm going to factor it out. Cosine, I actually have a cosine squared, so I can factor out cosine squared, which leaves me with 1 minus sine squared x all over sine squared x. Then I notice 1 minus sine squared is the same thing as cosine squared, so I can keep my cosine squared x, but I'm going to change my parentheses to be cosine squared x, because 1 minus sine squared is cosine squared. And I'm going to keep my denominator the same. And now remember, I'm trying to get cotangent squared times cosine squared. So I can already kind of see I have a cosine squared x, and I also have a cosine squared x over sine squared x, which we said in the beginning was exactly what we changed cotangent squared to. So we're just going to go backwards now and change this cosine squared x. We can separate it. So we have cosine squared x over sine squared x times cosine squared x. So I just pulled this cosine out of the fraction. I separated it. It's still exactly the same thing, because if I put this over 1 and I multiplied it back together, I'd be back to where I was. I'm separating it on purpose because now all I have to do is change my fraction back to be cotangent squared x and bring down my cosine squared x, and now I have my answer that I was looking for. I've now shown in every step how to get the answer to this problem. Because remember, they gave us the answer. They told us they wanted us to prove it. So basically, we're showing the steps to get the answer.